Jai Somnara.
క్లాస్ ఆడింద్రా సాయంత్రం పోదు.
Let everyone wait. Let everyone join. Okay, we'll wait for 2 to 3 minutes, then we'll start the session.
Okay, sir.
Inform everyone. Anna, inform.
Lens concepts.
Jai Swaminarayan.
Jai Somnarayan sir, good evening.
Jai Swaminarayan.
Swaminarayan sir, good
Jai
evening.
Swaminarayan.
Jai Swamnath sir, good evening.
Jai Swaminarayan.
Jai Somnath sir, good evening.
Swaminarayan.
Jai Somnarayan sir, good evening.
Okay. Shall we start? Still we have to wait for anyone.
No, sir.
Okay, I'll start the session now. What happened? Only 23 people are there. What about remaining? How many people are present in morning session?
Sir.
What about morning strength?
40 above, sir.
No, it is only 24, right?
Only 40, sir.
Morning 40. All 3 sessions.
No, sir, only math session 40.
Only math session, sir.
35, 40 sir.
40
Average
to
35,
45 for math session.
30, 35, sir. 30.
Okay. Okay, Nana. Let it. In last class, we discussed about the types of the lenses. One is convex, another one is concave. Okay. What is the structure of convex lens? How it will be?
It is bulged in the middle and thinner at the ends, sir.
Yes. Which bulges at the middle and at the edges it will be very sharp now. Like this it will be. Okay. Means in the middle it will be means bulging type of thing, means like it is coming out at the edges it will be sharp now. Okay, this is of convex lens. Come to the concave, how it will be there?
Middle it is thin and edges it is bulged, sir.
Yes, at edges it will be bulged out, in middle it will be bulged in. That is the structure of concave lens. But before discussing the thing, what the difference between the lens and mirror?
Sir, lens is a transparent object and mirror is a reflecting object.
Whereas in the
Sir, mirror, sir.
Reflection and
Sir,
reflection.
mirror
Sir.
has coating, sir.
yes,
And lens has no coating, sir.
okay, very good. Okay, please. Lenses can refract, whereas mirrors can reflect the light. Okay, are you clear, Anna? Now we people are going to discuss some important points. Okay, terminology of the lenses. Okay, first, whether it is a concave or convex lens, it having one center. That center is known as optical center. Okay, it can be represented by O, optical center. The center point of the lens is known as optic center. Okay, generally like this here it will be there. This is known as optic center. Okay, this can be represented by O. Okay, next. For this is for the convex. For the concave also same like this only it will be there. Okay, this is the center point. This is known as optic center. Optic center means the center point of the lens. Okay, the center point of the lens is known as optic center. It can be represented by O. Next, principal axis. Okay, we discussed a principal axis concept in the mirror concept now. What is meant by principal axis?
Imaginary line which passes through center of curvature, focus and pole.
Very good, Anna. It is a imaginary
And
line.
which may exist or may not exist.
Very good, Anna. Okay, it is a imaginary line which is passing through the which is passing through the optical center. Whereas in the mirror we can say which is passing through the pole. But whereas in the lenses we can say it as optic center. It is a imaginary line which is passing through the optic center, that is known as principal axis. Okay, generally the principal axis can be represented by like this. Please observe carefully. This is the convex lens, this is the optic center, and this is known as principal axis. Principal axis, are you clear now? So far we discussed only two terminologies, means two words. One is optic center O and principal axis. Optic center means the center point of any lens is known as optic center, whether it is a convex or concave. Remember carefully. Okay, last time one stupid asked, sir, you are saying about the concave, okay, center point as poles or what is meant by concave lens? Okay, for the convex lens as well as concave lens, for both the center point of that lens is known as optic center. It can be represented by O. Are you clear, Anna? That is about the optic center. Next, we discussed about the principal axis. Principal axis means the imaginary line which is passing through the optic center, that is known as principal axis. Are you clear, Anna? Please, if you want, anyone want to write the definitions, please note it down. First, note it down the definitions. Completed? Completed, Anna? Ramavatar completed? Next. Okay. Next one is tell me, Nana. Who is that?
Completed, sir.
Complete. Next one is focus. For the, please remember carefully, Nana, for the mirror, only one focus will be there. Okay. Why? Because the light comes from one direction and falls on the mirror and it reflects back and meets at one point only. Means either maybe right side or left side, like from which direction it is coming, from that direction. For example, for the concave mirrors, in which direction the light is coming and falling, in that direction only the focus will be formed. Whereas in the convex mirrors it will be in the other direction. Okay, why? Because concave mirror forms real images, whereas convex mirror forms virtual images. Okay, listen carefully here. But for the lenses, there will be two focus now. One is primary, another one is secondary. Primary focus and secondary focus. In your textbook, regarding primary and secondary focus, they did mention, but remember carefully. Primary focus means, for example, if the light is coming from the right direction, means right side, and it is a lens. That's why what happens, the light will refract, and it forms a point image on the principal axis. Okay, in which direction forms? At the left side it forms, means opposite direction. Okay, that point is known as primary focus. Primary focus. If it is from right side, the image formed will be, okay, point image formed will be at one point on the principal axis. That is known as primary focus. It can be represented by capital F1. Capital F1. Okay, the distance between optic center to primary. Tell me, Nana, what the problem? Okay, what you are saying, I'm not at all getting that. What Ramavata or something is saying?
We cannot
Sir,
hear.
his voice is not clear, sir. Not
Okay,
clear.
if anything you want to ask, please send a message, Nana. Okay, please listen.
Sir, once repeat, sir. I focus now.
Okay, just the light, if it is coming from the right side, the, okay, from infinite source on the principal axis at one point on the left side, one point image will be formed, and one point image will be formed. Okay, that is known as primary focus. Primary focus. Okay, it can be represented by capital F1. Okay, if the light is coming from the right side, image formed will be at left. Okay, that is called as primary focus. If the image means the distance between optic center to primary focus is known as focal length. The distance between primary focus to optic center, O to F1, that is OF1, is known as focal length. It can be represented by small f. Okay, the distance between, in the mirrors, the distance between pole to focus, will say, sir. In lenses, the optic center to focus is known as focal length. Are you clear enough? Next, for example, if the light is coming from right side, the, okay, focus will form at a focal length distance, means at f1 it will be forming. That is known as primary focus. Okay, towards left side also one more point image forms now. Okay, if the light is coming from left side, okay, at right side, listen carefully. Once I'll show you on that board, listen carefully. This is the convex lens. This is the principal axis. This is the optic center. Okay, if the rays are coming from right side, here on the left side, one point image will be formed. This is called as primary focus. Okay, it can be represented by F1. Primary focus, F1. The distance between optic center to primary focus is known as focal length, small f. If the light is coming from left side, then also refraction has to take place in this. Okay, then also one point image is forming on the principal axis. This is known as secondary focus. Okay, secondary focus. Here optic center to, Okay, secondary focus distance is also will be same. This is known as focal length. From here to here, from here to primary and secondary focal means focal lengths will be equal. Remember carefully, it can be represented by F1, this will be F2. F1 will be always equal to F2, that is equal to F1. This is known as focal length. Are you clear? Are you clear, Nana? I hope you understood the thing. Okay. Once you have textbook na, just go through that carefully, Nana. Once go through that. Okay, which is there in your textbook. Once go. After reading, please once show your thumb impression. Nana. Optic center, focus, focal length, primary and secondary focal length. After reading, once go. Show your thumb impression.
Sir, here also point image only.
Ramavatar, what you said I didn't get. Please.
Sir, here also, sir, in secondary focus, also point image is formed, sir.
Yes, obviously, Nana. If the light is coming from infinite, obviously at the focus, point image only forms. Okay. That is for the convex. For concave, I'll show you once again. First, go through that.
Sir, page number 117 only, sir.
Completed. Completed on everyone's. Make it fast. Completed. Okay. Now everyone go through activity 10.11, Nana, please. Next, center of curvature we have to discuss. Already, you know, I think center of curvature. Okay. 2f is equal to r radius of curvature means the distance from center of curvature means the spherical lens is generally formed by the spheres. Okay, the sphere center is known as center for that okay lens. Okay, are you clear? And it can be represented by c1 primary center of curvature, again secondary center of curvature c1 c2. Are you clear, Nana? That is only the thing, Nana. The distance from center of curvature to optic center is known as radius of curvature. In this radius of curvature also primary and secondary both will be there, Nana. R1 R2. Are you clear, Nana? Any doubt in it? Are you are you clear? Or any doubt, Nana? Any doubt in the radius of curvature?
No, sir.
Ragi,
No, sir. No, 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 no.
any doubt?
No doubt, sir.
Okay, Nana. Please, all the concepts like mirrors only, Nana. All the concepts like mirrors only. Okay, are you clear? Now go through 10.11 activity. Once go through 10.11 activity.
Completed. Completed, sir.
Completed. Activity completed, Nana.
Yes, sir.
Okay. Who will explain that activity, please? Just raise your hands. Yes, Kritik Tejas, tell me, Nana. Explain the activity.
Sir, the caution in the activity is we should not look directly through a lens while doing this activity. This will damage our eyes. And let us go into the activity. We should hold a convex lens in a very sunny day, and on a sheet of paper we should try to focus a highly diminished of point size image of the sun, and hold that position for a while. Now after some time, what will happen? The smokes from the paper will come and paper will start to burn because of very point size image.
Hello, sir. Just go through the concept carefully once again. Just go through the concept carefully once again. Ramavatar, just go through the concept. So far, I said about the converging and diverging lens. Whether you understood? Whether you
Yes,
understood,
sir.
sir?
Yes, sir.
Converging and diverging lens phenomena. Whether you understood, sir?
Yes, sir.
Yes, sir.
Converging and diverging phenomena. Okay, activity completed. Regarding activity, any issue?
No, sir. No, sir.
No.
Okay, 1 minute. Someone said. Here, convex lens. Once again, some student is asking. He didn't get what I said. Means some voice problem was taken place. Please listen carefully. If you are using convex lens, okay, all the rays, okay, will converge. Means meet at one point and forms a point image. That's why convex lens is known as converging lens. Okay, whereas if you use concave lens, what happen? All the rays will deviate. Okay, because of that reason, we can call concave lens as diverging lens. Okay, converging and diverging. Are you clear? Next, precautions, procedure completed, result, what we got, what we'll get, focal length will get, and by that, if you twice, you will get radius of curvature. Okay, that is the result and conclusion. At last, we have to discuss about the precautions. Whenever you are doing this activity, you should not see the sunlight or point image of convex lens directly by your eyes. Okay, that is a precaution. Remember carefully now. Okay, these are the some of the precautions you have to follow. And if you are using the candle, you should be careful with the light also. That is also a condition. Okay, for example, if you are using a candle, okay, that is about the lens phenomena. And this is about the today's concept. Please, any one student, please recapitulate what we discussed so far. Please recapitulate. Please, anyone, sir, anyone, explain today's concept totally what we discussed. Who will explain, Nana? Ramavatar, can you explain, Nana, today's concept what we discussed so far?
Sir,
Sir, your voice
yes,
is
sir.
also
Yes, sir.
explain.
Center, sir. Sir is already.
Okay, Nana.
Center is the center point,
Okay,
and
Nana.
you
It's
said
not
about
clear,
the principal axis.
Ramavatar, it is not clear. Please wait, Nana. SV Kritik Tejas, explain, Nana.
Sir, can I, sir? In
Kritik
a
Tejas, you
camera.
can. Kritik Tejas, you can.
Yes, sir. Yes, sir.
Ramavatar, lot of disturbance is happening, Nana. Sorry.
The center point of the convex lens is also called as optical center, and for both concave and convex lens, the center point is known as optical center, and the convex mirror is bulged in the middle and thinner at the edges, while concave mirror is bulged at the edges and thinner in the middle. Principal axis. Principal axis is an imaginary line that passes through optical center, focus, and center of curvature. Difference between mirror and lens. Mirror is a reflecting surface and it is coated, but uh, lens is a transparent surface and it is a refracting surface. Mirror have only one focus because mirror only reflects to one side, while lens have two focuses. Uh, the focus when the rays come from left to right is known as f1, and the focus of the light which comes from right to left is known as f2 because lens have two focuses. In convex lens. Now we will discuss about activity 10.11. In activity 10.11, we should take a magnifying glass or any convex lens, and we should place the lens under the sun so that a point image forms. After the forming of a point image, we should not move the lens or the paper. We should keep in the same position for a while. Now we should observe the paper, and smoke started coming from the paper if we kept for some time, and if we kept the lens and paper with not moving, and then we will see that the paper will start burning. This is because the concentration of the sunlight, because the sunlight is also a source of heat. If all the sunlight is concentrated at one point, then all the heat is also concentrated at one point, and then the paper will started to burn.
Very good, Nana. Okay, very good.
Thank you, sir.
Okay, today everyone prepare the synapses notes from this concept, and in science group keep, Nana. Some people still they are not doing the work. I observed. Okay, you should not do. You should not do like that. Why? Because your 20 marks is there. Sorry.
Till today night.
Tomorrow morning, Nana. Till tomorrow morning. I think tomorrow morning 6:30 also physics class only there.
No, sir. Friday, sir, physics.
Friday, sir.
Friday morning 6:30. Yeah?
Yes, sir.
Yes, sir.
It's
Okay.
a Friday.
Okay. I think 27th you have G Brilliance exam on 27th.
Sunday.
Okay.
On 27th you have. Yes. Okay. Try to prepare the notes, Nana. Okay. And keep
Sir,
in
in
science group.
sir.
Thank you.
Sir.
Sir, in Google
Nana.
Apps, sir, the exam.
Sir,
G Brilliance, all that I don't know. I don't.
Sir,
Okay.
voice is breaking,
Anyway,
sir. Voice is breaking, sir.
sir, we should keep total lesson, sir.
and Jai Swaminarayan.
Sir,
Sir,
Not
Sir.
total lesson. Not
up to today's concept, sir.
yes. Okay.
Okay, sir.
Okay, sir.
Leave the session. Nana. Thank you.
Okay.
Jai Swami.